In this final video dedicated to protecting groups, I'm going to be discussing viable protecting groups for reactions that involve aldehydes and ketones and also amino groups. So how can you protect aldehydes and ketones, carbonyl groups and amino groups from undesirable reactions? So what are you aiming to avoid? What sort of undesirable reactions you're aiming to avoid when you're protecting aldehydes and ketones? Well, the oxygen in the carbonyl group can act as a weak base, so it can be involved in, it can get protonated. Also, aldehydes and ketones are subject to, it can be subject to nucleophilic acyl addition. For example, by a Grignard reagent, if you have a ketone or an aldehyde with a Grignard reagent of some description, you could end up with an alcohol and a carbon chain and destroying that carbonyl group. Another problem could be, for example, in a nucleophile, let's say some nitrogen compound or ammonia. You could end up generating an imine and losing that carbonyl group. So what can you do? Well, one thing you can do is to reduce your carbonyl group to an alcohol, protect the alcohol, and then once the reaction, the synthesis has finished, oxidize your alcohol again to a carbonyl group. The problem of that, it involves quite a few steps, because there is the reduction of the carbonyl group, then to an alcohol, the protection of the alcohol, and then the deprotection of the alcohol, and then the oxidation to return to the original carbonyl group. So instead of just 2 steps, protecting and liberating the functional group, you actually have 4. Another less step-intensive option is to convert your carbonyl group from aldehyde or a ketone to a ketal or an acetal, or if you're using sulfur compounds, you can also use sulfur protecting groups, a dithioketal or dithioacetal. So, for example, this is an example of how you can protect a carbonyl group. In this case is an aldehyde, by using a dithio compound, and so the carbonyl group, the aldehyde, disappears, and you produce the dithioketal compound. There's a series of reactions, and then when you are ready to, when the synthesis has finished, you can liberate you can remove the protecting group and recover the original functional group, the original aldehyde that was being protected. In the first reaction in this slide, this is a really nice example of the use of a diacetal to protect a carbonyl group. So you're aiming to have a carbonyl group, an aldehyde, in this case an aldehyde, in that part of the molecule, and you start the synthesis by bringing that carbonyl group, but in a protected form, in the form of a diacetal. You do the reaction to generate the part of the molecule you're interested on changing and keeping this as a diacetal, and then as a final step, by using concentrated acid, you liberate the diacetal and hydrolyze the diacetal, and you form the aldehyde. And the second reaction is again shows an example, in this case the formation of a ketal. So you form a ketal to protect this carbonyl group, this ketone group, do a series of reactions to modify the rest of the molecule, and when at the end of the reaction, by using acetic acid, you hydrolyze the ketal and liberate the carbonyl group, the original ketone that had been protected throughout the whole synthesis. Amines are another functional group that often is protecting. Why? Well, amines, what you're aiming is protection of this lone non-bonding electronic pair that amines have in their structure, primary, secondary, tertiary amines. That means that they can act both as bases, they are weak bases, and they can also act as nucleophiles. So a way to protect that amino group is, removing the existence of this lone pair by forming the quaternary ammonium salt. And that means that ammonium salt cannot be, that nitrogen does not have a non-bonding electronic pair available to participate in alkylation reactions or in acid-base reactions or even to undergo oxidation. There are problems with using converting amines to ammonium salts, which is that there tend to be problems with solubilities, with the solubility of the salt in common organic solvents. There's also the issue that quaternary ammonium salts are themselves good leaving groups, so they are prone to substitution and elimination reactions. So you might end up accidentally losing your amino group when you were trying to do is protect it. A different way of protecting that lone pair, that non-bonding electronic pair, is reducing the basicity and the nucleophilic ability of that electronic pair. By making that electronic non-bonding pair more delocalized across the structure, so it's not so available for nucleophilic and acid-base reactions. You can, for example, convert a primary or secondary amine to a tertiary amine. You can also convert amines to amides, and finally you can convert amines to carbamates. And in all those ways, you are protecting this lone electronic pair. This is an example of a reaction in which an alkyl group, or in this case, a benzyl group, is used to protect an amine. So here, the amine already carries the benzyl group. You make it react with an acid chloride. You form a tertiary amine, and the benzyl group is there. There are a series of reactions that take place across the rest of the molecule to form the final product. And finally, by using sodium and in ammonium as solvent, you remove the protecting group, this benzyl group, and recuperate, generate an in this case is an amide, but liberate that position in the nitrogen and recuperate a hydrogen. You can, instead of N-alkyl groups, use N-silyl groups. And this is an example of, this is an example of a reaction in which you use TMS, trimethyl-silyl, in this case chloride, to protect a primary amine. A series of reactions happen, and then finally, using hydrochloric acid, you remove the protecting group and recuperate the original primary amine. Another way of protecting an amide is by converting it into an amide, and it's particularly popular to use to convert them into an acyl amine, an acetamide. So this is an example in which you have a secondary amine, and it's protected by using acetic anhydride. So you form the acetamide. You do a series of reactions across the rest of the molecule to obtain the desired compound, and then in the final step, by using trifluoroacetic acid, by using an acid, you remove the protecting group and recuperate the original secondary amine. Finally, another way of protecting an amine is by forming a carbamate, and it's particularly popular to use terbutoxyl carbonyl as protecting group. So this example, for example, of quite a complicated reaction, what you're aiming to protect is this nitrogen here. So you use a terbutoxyl carbonyl anhydride. This position gets protected. A series of reactions happen, and the structure of the molecule changes quite dramatically. but this nitrogen is still protected. It's not interfering with the rest of the synthetic steps. And finally, again, by using an acid, in this case trifluoroacetic acid, the nitrogen gets liberated, the protecting group gets removed, and you regenerate that hydrogen in that what is now a secondary amine. This is the end of the videos dedicated to protecting groups. As you can see, there are quite a few things that you need to take into consideration when using a protecting group. The first step is, do you really need a protecting group to start with, or is it possible to do the reaction by introducing the functional groups, perhaps in a different order, to avoid a protecting group? Because every time you use a protecting group, you have two extra steps in your synthesis. One to add to the protecting group, and the other one to remove the protecting group. However, sometimes it is necessary to use protecting groups, and then there are quite a whole array of protecting groups available. But as you can see, they tend to be all based on the same principle. Reducing the lability, the reactivity of those particular functional groups, specifically hydroxyl groups, amino groups, and carbonyl groups, especially from ketones and aldehydes, which are the typical groups that you might want to protect in an organic synthesis. So this is all from me. I hope it was useful, and thank you very much for watching.